Hello, everyone. Welcome to a new episode of our Lunch and Learn series, where we bring interesting topics from the world of tech and development to you. Remember that if you're watching us live on YouTube, you can ask questions using the chat, and we will answer them at the end of the stream. Today, we have Rodrigo Murillo, who works with Create Interactive. He is working there as a WordPress developer, right? He will talk to us about CSS variables and calculations. So let's hear what Rodrigo has to say about this. It's definitely an interesting topic. I am a backend developer, so I have no idea about CSS. I am very interested in today's topic, Rodrigo.
Thank you very much, Sebastian. Actually, it's quite an interesting topic indeed. As a WordPress developer, we deal with front-end, like 80% of our work is basically front-end. So we deal with a lot of CSS and layouts. And from time to time, we come with these interesting concepts and ideas. And this is something I stumbled upon some time ago, and I was really happy with this opportunity to share. So I hope that you find this interesting as well. And that it sparks new ideas, because today we'll see CSS variables and calculations with the focus on creating animated websites, but that's just one application for this concept. I'm sure you guys will find tons of other cool stuff to do with this. So thank you for the introduction. I am Rodrigo Murillo. I'm from Cusco, Peru, and I work with the open source team at Create Interactive. So without further ado, let's dive into the topic.
Sure.
Okay.
Thank you for the start. Take it away, Rodrigo.
Excellent. Thank you. So first, I want to start running a short overview of what CSS variables are and the calc function and how they can work together to create cool stuff. So let's start by taking a look at CSS variables. So this is some CSS from the good old days when we didn't have like preprocessors or any other tool, and we had to write like plain CSS to create our layouts and stuff. To the right, we are seeing two green squares. That should be like the result for this bit of code, of course, with some more styles. But as you can see, we're creating just a two-column layout. We are using Flex, and we have some CSS for that. For instance, we have some negative margin for the containing element, so that it spans a bit wider than its own container. And then our columns have the same value. This is important, right? The same value, 20 pixels, 20 pixels. So in that manner, we would create this kind of layout. So it's not important, actually, like the details for this, but just to take a look at this value, the 20 pixels, that it's the same. So if we wanted to change, for instance, the gap between these two elements, we would have to go back to our style sheet and find all the instances of these 20 pixels and update it, let's say, to 30 pixels or something like that. So that could get a bit tedious. That was one of the issues that preprocessors solved, among many others. So when using preprocessors, we would write the same code in this manner rather than the previous one. So we would have something like this. Let's say this is a variable declaration within SCSS for column gap. We're aiming for a 40 pixel separation. That's two gaps of 20 pixels combined. So this code creates the same result that we've seen in the previous slide. So as you can see, we have the calculation over here. As the name implies, it's a preprocessor. So this tool, SAS or LESS or Stylus, will take all this code, and from this source code will generate a new style sheet with the values that we want. For instance, in this case, we would have the negative 20 pixels here at the top and just 20 pixels here at the bottom. Okay, so variables were very cool within preprocessors, and that's why they became a native feature within CSS. So all major browsers started adopting variables, and we had a new specification, and it became a thing. So what's cool about this is that it allows us to do basically the same thing. As you can see, we are defining a variable here at the root element. So this is document element declaration. And we are using the same variable. We are using the function calc, which we will see in a couple of minutes in more detail. But this is for creating the same example. Okay, so this will also be computed to the same output, the same negative 20 pixels at the top, the same 20 pixels at the bottom. If we want to update the width of this gap between columns, we just need to update this variable over here, and all the values will get updated. Okay, so that's how it works with CSS variables. And now, what makes CSS variables great? Of course, they solve this this problem of having to repeat the same code over and over again. We don't have to do that anymore. But they introduced some new cool features, some features that even preprocessors don't have, or they don't allow. So first, we have this concept, this global concept of CSS in general, the C being from cascading. So variables enjoy cascading inheritance. They also have this property. So any child element within the document will inherit all variable values from their parent. So as we saw in our example, we were defining these values in the root element. That's document level definition for these variables. So everywhere in the site when we use this variable, it will inherit that value. So that's a cool feature of CSS variables, and it allows for 3 types of overrides or uses of that inheritance that we will see. For instance, we have global overrides. This is what we were discussing. For instance, let's take a look at that CSS code to the left. It's just a portion of a CSS style sheet with some properties for the body element. Okay, we are defining a font family, a font size, a line height, a background color. Okay, to the right, we have 2 alternatives, alternative style sheets with declarations for those variables. So the first one uses some warm colors. It uses some red for the accent color. It uses a Roboto for the font family, and we have like values for the font size as well. So the second version, the one to the right, uses warm colors. It uses blue. It uses light blue, and it uses a different font family. So this is a pattern of doing, for instance, theming. We could have one big style sheet that uses or consumes all these variables in different spots for buttons, for lists, for boxes. And then we could just write the variations that we need in a separate style sheet or something like that, that has like the values for those colors, sizes, spacing, etc., etc. So here's a good example of this. This is an admin dashboard, a customized WordPress dashboard for 2 different projects that have been branded accordingly, and they use this concept. So we have one main style sheet that is ready to consume a set of variables, and we only need to update those to create a different theme for that dashboard. There is also this concept of local overrides. So as we were seeing, this cascading inheritance concept allows us to update the value of any of these variables at any point within the document. So in this case, let's take a look at this piece of code to the left. And we have our main variables being declared at root level. Then we have the button class that uses those variables. So any element that has the button class will have a background with a reference to the button background variable and a color to the second variable. And then we create a third class. This third class doesn't have any properties. It just overrides the values of the variables that we defined at root level. So what happens here, as we can see here at the middle of the screen, we have the HTML. We have a first button with just the button class. And then the second button has both classes. The button class that has these property declarations that use the variables, and the second class, a modifier class, that updates those values. As you can see to the right is the resulting elements being rendered. So we have this primary button that has this hot pink color, and the second button has those values with a different set of colors. So that is pretty cool. We can just by assigning this second class to the second element, we are overriding the values of those variables, but the element, since it has the same button class, it knows how to use those variables for its properties. So that's what I call a local override. And then this is also cool about variables. It's context-based overrides. So I don't have to always override the value of a variable at the within the same element that I want to change. In this case, as you can see, we have the same root variables, the same button class, but we have a new class, blue background, it's called. And it has, well, a blue background. And then it has new values for the same two variables. So any button element that lives within this blue background element will use different values for its properties. So that's pretty cool. This is the HTML that produces the same result. And as we can see to the right, we have like two sections, one with a white background that uses the default button colors. And then the blue background section, it uses new values. So this element, the A tag that has the button class, will now use the values from the closest parent that has a declaration for those variables. So that's a pretty cool way, a pretty useful way also to like update tons of colors within one containing element without having to nest some style or create complicated selectors. The other cool feature about CSS variables is that they are rendered, let's say, in real time. So all the web is actually rendered in real time. If I go to this presentation, I inspect the code and start making some changes to the CSS properties, I will see those changes live. But the thing with variables is that the browser uses a reference to that variable instead of the actual value. So let's take a look at preprocessors. When we were using preprocessors for using variables, all this code will be compiled into this code to the right. Okay, so we will have the desired value, minus 20 pixels and 20 pixels, but we wouldn't know how that value came to be. We wouldn't know where it came from. We would lose the reference to this 40 pixels gap that we wanted to create. When we use CSS variables, this is the CSS output that the browser uses, and it will remain in memory, and the browser will still have all these formulas when you inspect an element. And so that's what I was referring to when I talked about real-time rendering. It's because if I go ahead and change this value in real time, all the references will be updated in the rendering. So let's see an example. I have a quick example for this. This is a fictional site. As you can see, it has this really nice dark blue color that's being used in many places within the site. So I'm going to go ahead and inspect this element over here, this call to action block. Okay, I have the container. Which one is? Okay, I think, oops, here it is. Here is the CSS for this element. As you can see, it has the background, but it doesn't have the value. It's not the hex code of this color. It's a reference to the global accent variable. So if I click here, I will go to the declaration of this variable. I have some other variables over here. If I go ahead and click on this button and make a change in real time, you will see that I'm only changing one place within my style set, and everywhere where this color is used is being updated. I can go for a very cool green color or something like that, and everywhere will be updated. And again, I'm not updating values. I'm updating just the value for this variable. All the other elements are preserving the reference to that variable. So that's pretty cool. Okay, let's go back to the presentation. We will see in a moment how this comes to life in a even cooler example. So now let's take a brief walk through the calc function. So the calc function, we saw some examples earlier, but what it basically does, it allows us to create a mathematical formula, just a calculation that the browser will need to do again in real time to get the value of a given property. So in this example, as you can see from the code, we are given the width of this element. We know that an element that is given a width of 100% will span like the width of its own container, right? 100% of the available space. So when we add this code, calc 100% minus 60 pixels, we're telling this element to span as wide as possible minus of those 60 pixels. So that is pretty cool because this element now becomes very flexible, very responsive. If we go ahead and resize our window, we will see this element just fitting that space within that rule, leaving 60 pixels. And we are also doing that for the height of this element, 100 viewport height minus the value of a given variable. So as you can see, the calc function is very powerful. It allows us not only to mix and match values, but also combine them with references to variables. So that is also pretty cool, and there is tons of potential there. And that's exactly what we are about to see, like CS variables and calc and how we can combine them to create some cool effects. So as you can see from this example, this reminded me a lot to what we saw in school, in math class, these mathematical functions, like function of x, and it will always be like x divided by 4 plus 100 pixels. So whichever value you give to x, which will be our variable, the resulting value will be that value divided by 4 plus 100 pixels. So it's pretty powerful to have this ability within our CSS. As you can see, both concepts, they have this real-time rendering. The formula and the references to the variables are stored within the browser, and the browser knows exactly how that formula goes. So if something changes inside that formula, the browser will react in real time. And this ability of the calc function to mix and match values and variables, we will see with some examples how that works. So let's go to example number 2. So this is a very fun piece of code. It's a rocket. It's made mostly with CSS. There is very little JavaScript in this page, just a bit. So here at the bottom with these controls. So what these controls do, these are mapped to a couple of CSS variables. Let me open the inspector here for us to see. So let's take a look here at the body element. As you can see, we are updating a value for this element using a CSS variable over here. If I go ahead and change the angle of this element, the rocket will rotate, but not only the rocket will rotate, also, as you can see, the stars change the direction in which they are moving. Because as you can assume, we have plenty of properties, plenty of CSS declarations that have references to this variable. And we have a second variable over here, which is pretty cool, the engine, the thrust. So we can give it like full thrust here, and we will see this nice animation. And you will see that many aspects of the rendering will change depending on these two variables. For instance, well, the more evident is the amount of particles that are, and the size of the particles that go from the rocket's engine. But also, as you can see, the rocket is shaking a little bit. So I thought this was very cool, a very cool example. As you can see, we are only changing values here at the body element, and we have tons of code. Let me see if I can bring some of that code that are referencing those variables. So here's for the rocket. As you can see, the rocket elongates the more power we put to the engine. So we have this scale y function that uses a calculation of 1 plus the value of this variable divided by 100. That's because I could have used a value between 0 and 1, but these letters go from 0 to 100. So I had to divide everything by 100 in my code. It would have been easier to go from 0 to 1. But in any case, we can see that these variables are being referenced all over the place, even within an animation, which is pretty cool. As you can see, the cabin, the body, the legs, they all share this animation over here, which is called rocket shake. And here within rocket shake, it's an animation that goes from minus x-axis minus something towards plus the same value, right? So we go from, again, just a calculation involving the rocket speed minus 2 pixels. So it will be a fraction of minus 2 pixels. And the rocket goes from that value to 2 pixels to the right. So if I were to, let's make a more exaggerated effect over here. So as you can see, now the rocket is clearly shaking. But it's cool that we can even use those CSS variables within animations and keyframes, and it will work well, as expected. So this was a very cool and fun project. I wanted to show you also more like a real life example of how we can use this. So as you could see from the previous example, the rocket, we had some JavaScript involved. It's not pure CSS. We also have some very cool JavaScript libraries for creating animations, but sometimes they can get a bit cumbersome. They have a different syntax. We have to learn something new in order to use them. I found this, that for cases such as this, which is also from a real site, we could get away with using just CSS variables. So in this case, there is some JavaScript involved as well. Let's imagine a big rectangle over here. And as we scroll through that rectangle, a CSS variable will be updated from 0 through 1. So if I go and inspect this code, I'm going to bring it to the bottom here. Let's see. You will see we have plenty of places where we have this scroll bar. This is the one that was used for this site. And as we scroll through the site, the value will be updated from 0 through 1. And as you can see, we have some effects that use these values, some rotation of this circle of dots. Then these texts also appear on the screen. And if we go ahead and inspect one of these, we will see, for instance, for this element, the opacity uses a reference to that scroll bar. So the farther I scroll, the less transparent this element becomes. And combining the opacity with some translates and transforms, we create this nice effect of these circles, like moving, and then the text appearing a bit to the left. And that was something that was really cool to achieve. In this same page, we have another cool example. So we have this slider over here. It has some concepts and some icons. And as I scroll through them, you can see the wheel turning. It seems a bit simple. It has a combination of different transformations. For instance, when the wheel turns X amount of degrees to the right, all the icons need to turn the same amount to the left, so they are still facing in the same direction. So I'm going to go ahead and click on one of these and take a look at the CSS. Here you can see the transform rule for this element. So oops, I think it's scroll. Okay, here we have it. So as you can see, it's a mathematical function again, that the rotation depends on plenty of variables. First, the index of the image. Every image has an index. As you can see, this index is defined for each one of these elements. Here in the code, this is index 0, index 1, index 2. So the wheel image will have a rotation that depends on also on which index it is, times 360 degrees divided by 5. So we have 5 sectors for this circumference. So that's why we are dividing 360 and 60 by 5, minus the current wheel rotation. So and we also scale these variables. The one that is selected is bigger than the rest of them. And it was a pretty cool use because as we are scrolling through the site, what really changes is, well, we have some JavaScript that adds this active class to the slides. But if I go to the container, I will see. Oh, let me find this. Oh, it's in the wheel. Sorry, I'm selecting the wrong element there. Here, I have some styles for this wheel element with the data current value. So my JavaScript code is updating this value. We can make sure that our animation will work as intended. And the JavaScript part for this wheel was actually fairly easy to write because everything, all the computations, rotations, and the rest of this layout was already solved for in the CSS. So yes, those were the 2 examples I wanted to show you, and I'm sure you guys will get tons of ideas from this combination of the CSS function and the calc function and CSS variables. So yeah, well, thank you very much for your time, and I hope that you really enjoyed this as much as I did.
All right. Thank you, Rodrigo. That was very, very interesting to watch, especially that final example with everything actually taking place, things spinning, things rotating, things moving from one side to the other. That was very, very cool to watch. And to watch it actually happen live as you were editing the variables, that actually, I think, made it click, what was taking place. That was very interesting. Let's see if there are questions in the comments here on the YouTube chat. There is one question here. It's asking whether SAS was involved in any of the examples. Is there any library that manages the CSS there, something in the background, or is this pure CSS?
Oh, well, yes. I used SAS because I really love preprocessors. They save tons of work, but everything that we saw could be written just using plain CSS. So for the Racket, I am using SAS just to create these nested selectors. But if I go to the style sheet, oops, what's the name of this file? Just 1 second. If I go to the style sheet for this file, Rocketman, okay, of course. This is the CSS where we have some reset over here, but we will have everything that we just saw. All the references to the variables are here, so we could write this as plain CSS, and it would work as expected. So the reason I used SAS is because I had to run some loops. I think I have some code that repeats itself. Perhaps not in the CSS. Perhaps for this project wouldn't have been necessary. But yeah, so preprocessors are not a requirement to achieve these kinds of effects. As we were saying, CSS variables and calculations, those are native CSS features. So you could write those with plain CSS. You could write those using stylus, SAS. No big difference.
I have a question for you about this using CSS variables and calculations. As you said, we can either do it on the CSS part or use some JavaScript library or JavaScript function to perform this uh, in the code part. Is there any benefit to using CSS, whether it's load times or size of the bundle of the client page? What are the benefits of using CSS instead of using JavaScript?
Oh, that's a really great question. So when it comes to performance, there are tons of stuff that you need to be focusing on. For instance, from this example, as you can see, oh, oops, I think it's the last one. Okay, here we have it. So turns out that CSS is very, very performant. There are some JavaScript libraries that will also perform very, very well. You have to, like, in terms of performance, you have to take care of which properties you are using to create these animations. For instance, as you can see, this is a very large PNG. So this first section of the site is not as performant as the rest. If you go to the live site and start scrolling, you will notice some bumping. You will also have to be very careful with the JavaScript you use. For instance, for this website, I'm using an event that triggers on every scroll, but the page is not being updated on every scroll. You are using this function called request animation frame, which is something browsers have that you can tell them, hey, the next time you're going to update what you're showing to the user, run this calculation. Because if I hook those triggers only in the scroll event, I will get this event fired thousands of times as I'm scrolling through the site. So that's something to take into consideration. So yes, it wouldn't hurt to always consult. For instance, if I'm trying to use transforms to create these effects, just do a Google search and see how that will impact performance. If you want to attach something to the resize event or to the scroll event, also a simple Google search will show you these like studies and experiments that people have done to benchmark what kind of implementation works best. So that's exactly what I did here, because I am no wizard or guru or anything at JavaScript. So I had to Google a lot just to make sure that I wasn't hitting performance very hard. But it will come in a case-by-case scenario. Sometimes you will try to animate a very large element that has box shadows and gradients and stuff, and it might get a bit cloggy. So it's always good to run tests and measure performance yourself to see that you're doing things right.
All right. Thank you, Rodrigo. That was very illuminating. It was very interesting to see, me being a backend developer myself, seeing all of this magic happening in front end and actually seeing the logic behind it so easily readable on the CSS. Very cool to see. Thank you, everybody who tuned in to watch today's episode. If you have any further questions, or if you want to see some of our past Lunch and Learns, remember that every single recording that we do is on our YouTube channel, and you can keep the conversation going either in the comments or in our Slack. As usual, you can find us there and ask questions or let us know what other interesting topics you would like to see in the future. Make sure to give this video a like and tune in for the next one. Until then, have a good one, everybody.
Thank you very much.